Okay, so we're continuing now on page 16. And because we now know that the solution of an equation in two variables is an infinite number of ordered pairs, and we know the easiest way to represent an infinite number of ordered pairs is to graph those ordered pairs and form a line, because when we put arrows on the line, we're showing it goes on forever. Now, first, let's think about what is the domain. The domain are our possible x values. Well, when you are not given a domain, when you're just given an equation and you're not given a domain, you assume your domain is all real numbers. So in this case, our domain is all real numbers. So to graph this, what we're going to do is step one, we're going to solve this equation for y. So that's easy. We just subtract x from both sides, and we get y equals negative x plus 4. Now, let's go over why I said negative x plus 4 and not 4 minus x. And it's because last year you guys learned the slope-intercept form, y equals mx plus b. So whenever possible, we're going to put it into slope-intercept form. Next thing we're going to do is make a table. Okay? Now, you may know how to graph it from y equals mx plus b, but we're going to graph it from using a table. Now, my domain is all real numbers, but obviously I can't choose all real numbers. So, numbers to choose, good ones, are ones that are around the origin. So I'm going to choose negative 2, negative 1, 0, 1, 2. And after a while, we're only going to choose 3 domain values when we know the equation is linear. And since we've learned how to identify linear equations, we know this one is linear. So technically, we only really need to choose 3 values, but we'll stick with the 5. So the opposite of negative 2 is 2. 2 plus 4 is 6. This is 5. This is 4. This is 3. This is 2. Okay? So I have chosen my domain. Now, let's turn the page, and we're going to graph this. Here we go. So, I'm going to take the point negative 2, 5, negative 2, 5, negative 1, sorry, it was negative 2, 6. I did that wrong. Negative 2, 6, negative 1, 5, 0, 4, 1, 3, 2, 2. And now I'm going to think, should I connect these dots? Well, this says when you are asked to graph a line and you are not given a domain, your domain is infinite. If you are given a domain, your graph is just a set of points, not a continuous line. Well, in this case, I chose my domain, and my domain was all real numbers. So since it's all real numbers, I'm going to connect these and put an arrow. So by connecting these, I am showing that this is an infinite number of ordered pairs. And so I have just graphed my equation. Okay? Now, we're going to skip example 2 for a second, and I want everyone to turn to page 18. So, on page 18, we're going to do number 1. Now, to do number 1, it's asking us to graph this, and we are going to graph it by choosing a domain, deriving the range, and then graphing the points. So, step 1, and this is how you're going to have to do on your homework. Step 1, solve for y. Well, it's already solved for y. Step 2, make a table. Okay, and choose a domain. Choose a domain. So everyone should write these notes. First, you're going to solve for y. Step 2, you're going to make a table and choose a domain. So I'm choosing a domain because I'm not given a domain. So I'm going to choose -1, 0, 1. Okay? If I plug in -1, I get -2 minus 1 is -3. 0 minus 1 is -1, and 2 minus 1 is 1. Now I'm going to graph -1, 3, 0, -1. Ooh. I did not do that right. Okay. -1, -3. 0, -1, 1, 1. Connect my dots. Let's think about why I'm connecting my dots. I'm connecting my dots because I was not given a domain. So my domain is not restricted. It's all real numbers. So step 3 was graph the points. And step 4, connect and make a line. Or we really should say connect and decide whether you should make a line, or decide whether you should connect. Okay? So that's number 1. Now, let's look at number 3. Number 3 says, graph this if your domain is -1, 0, 1, 2. So, in this case, is my domain all real numbers? And the answer is no, because it gives me a domain. I am restricted. I cannot choose my own x values. I am given x values. So for number 3, step 1, solve for y. It's solved for y. Step 2 is make a table and choose a domain. Well, I can't choose a domain because I'm given a domain. So I have to use the domain values they provide for me. Then I plug in my numbers and I get 5, 1, -3, -7. Because if you plug in 2, you get negative. Did I write this? Okay, let's see if I did this right. So if I plug in -1, this becomes 4 plus 1 is 5. If I plug in 0, this is 1. If I plug in 1, this is -3. And if I plug in 2, it's -7. Yes. Okay, now let's graph these. So -1, 5, 0, 1, 1, -3, 2, -7. Now the question is, should I connect these dots? Should I connect? And the answer is no. Domain has 4 elements. Graph will only have 4 points. Okay? So, I do not connect the dots. If I connected the dots, I would be wrong. It does not say that if I connected the dots, I would be saying numbers in between 0 and -1 are included. They are not included. There's only 4 domain values I can consider, so my graph is just 4 dots. Okay, so now let's turn the page again to page 19, and let's look at example 3. And this says, graph the function y equals 2x plus 2 with a domain x is greater than or equal to 0. Then identify the range of the function. So, my domain is restricted. It's not all real numbers. It's just all positive numbers. So, first thing I do is solve for y. Well, this is solved for y. Step 2, I make a table. Choose my domain. Well, when you're given an inequality as a domain, this must be your endpoint. The first number you must choose must be from that inequality. So, I choose 0, 1, 2, 3, 4. I plug in these values. I get 2, 4, 6, 8, and 10. The next thing I do is plot the points. So I plot 0, 2, 1, 4, 2, 6, 3, 8, 4, 10. Now, the question is, do I connect these dots? Well, the inequality is continuous, but it has an endpoint. So I should not do a full line because I can't go in this direction. What I do is I graph a ray because the domain is restricted. Okay, so down here it says connect the points with a ray because the domain is restricted. Notice now the only x values considered are positive x values. Now we have to consider what our range is. Well, if you look at our table, what is the lowest y value? It is 2. Look at our graph. What's the lowest y value? It is 2. So, our range is y is greater than or equal to 2 because it's also restricted depending upon the x value. Now, I want you to notice my domain is an inequality. X is greater than or equal to 0. My range is also an inequality. Y is greater than or equal to 2. That's not a coincidence. If you look back to page 18, okay, on page 18, number 3, when my domain was -1, 0, 1, 2, I had 4 elements in my domain. My range was 5, 1, -3, -7. There's a consistency there. Look at number 1. For number 1, my domain was all real numbers and my range is all real numbers. So notice there must be similarity between your domain and range. If your domain is all real numbers, your range is probably all real numbers. If your domain is 4 elements, your range is probably 4 elements. If your domain is an inequality, your range is probably an inequality. Okay? Now, I want to go over something else before I let you do an example. We're going to go over this concept of discrete versus continuous graphs. Okay? This got cut off. This is restricted domain, limited number of points. Okay, so when you see just points, that's a restricted domain. And this is considered a discrete graph. I want you to think of this as 4 little buttons on a Velcro tablet. I can go up and take this button off, and that button will come off and not disrupt the other buttons. But here, all of these buttons are connected to a thread. If I pulled one button and lifted it off, they'd all come. That's the difference between discrete and continuous. Continuous means every point in between these points are considered. It's continuous. Pull one, they all come off. Here, there's no string connecting them. That is discrete. Okay? Now, also look down below, and I talk about always include the minimum or the maximum point in the domain. If you ever have an inequality, x is less than -2, you start with -2 and go lower. X is greater than or equal to 8, you start with 8 and go higher. X is less than or equal to 0, you start with 0 and go lower. And the ranges will also be inequalities. Okay, so now I want everyone to try checkpoint number 5. You're going to